Assalamualaikum and hello everyone. My name is Siti Khadijah binti Ahmad Taufik, metric number CN210366. So this is my video assignment for course of Waste Management Technology. This video is an individual assignment for Waste Management Technology course. The product of life cycle assessment that has been chosen is fertilizer. What is a fertilizer? A fertilizer or fertilizers is any material of natural or synthetic origin that is applied to soil or to plant tissues to supply plant nutrients. Fertilizers may be distinct from living materials or other non-nutrient soil amendments. Many sources of fertilizer exist, both natural and industrially produced. The use of fertilizers are added to crops in order to produce enough food to feed the human population. Also, fertilizers provide crops with nutrients like potassium, phosphorus, and nitrogen, which allow crops to grow bigger and faster and to produce more food. Why fertilizers are used? As we know, without fertilizers, nature struggles to replenish the nutrients in the soil. When crops are harvested, important nutrients are removed from the soil because they follow the crop and end up at the dinner table. If the soil is not replenished with nutrients through fertilizing, crop yields will deteriorate over time. There are two main types of fertilizers, which are organic fertilizers and inorganic fertilizers. What is organic fertilizers? Organic fertilizers are made from natural materials such as manure, compost, and peat moss. Organic fertilizers are generally easier on the environment, but they are slower acting than chemical fertilizers and they can cost more money. Inorganic fertilizer is made from chemicals such as nitrogen, phosphorus, and potassium. These chemicals can be found in many different combinations to match the nutrient needs of specific plants. Inorganic fertilizers can be very effective, but some people worry about using them because they may run off into local water supplies or damage soil organisms like earthworm. So, what is life cycle assessment or LCA? A life cycle assessment (LCA) is defined as the systematic analysis of the potential environmental impacts of products or services during their entire life cycle. So, life cycle assessment consists of resources, processing, manufacturing, distribution, use, and end of life.
Life Cycle Assessment (LCA) framework is based on four main phases: 1. Goal and scope, 2. Inventory analysis, 3. Impact assessment, 4. Interpretation.
The first phase is goal and scope phase. In this phase, main methodological choices are made in this step, in particular the exact definition of the functional unit, the identification of the system boundaries, the identification of the allocation procedure, the studied impact categories and the LCA models used, and the identification of data quality requirements. Second is inventory analysis or life cycle inventory (LCI) phase. This phase involves the data collection and the calculation procedure for the quantification of inputs and outputs of the studied system. Inputs and outputs concern energy, raw material and other physical inputs, products and co-products and waste, emission to air, water, soil and other environmental aspects. Data collected concern foreground processes, for example, for a consumer good manufacturers, the manufacturing and packaging of a product, and background processes. For example, for a consumer good manufacturers, the production of purchased electricity and materials. Data are validated and put in the relationship to the process units and functional units. In inventory analysis, for each stage of a product life cycle, data on emission into the environment and resources used are collected in an inventory. For each emission in the environment and resource, use are then characterized in term potential impact in the LCA, covering a number of impact categories. Third is life cycle impact assessment (LCA) or impact assessment phase. In the life cycle impact assessment (LCA) phase, LCA results are associated with environmental impact categories and indicators. This is done through LCA methods, which firstly classify emission into impact categories and secondly characterize them to common unit so as to allow comparison. What is impact assessment? This is include climate change, eutrophication, land use, resource depletion, acidification, ozone depletion, and others. Lastly, life cycle interpretation phase. Results from LCI and LCIA are interpreted in accordance to the state, goal, and scope. This step includes completeness, sensitivity, and consistency checks. Uncertainty and accuracy of obtained results are also addressed in this step. The area of protection are human health, ecosystem health, and natural resources. What is the stages of fertilizers or life cycle assessment (LCA)? From the diagram, you can see that the fertilizer life cycle starts with raw material acquisition, followed by the manufacture of fertilizer. Then, the third stage fertilizer life cycle is the distribution of the product for usage later. And it finally comes to the end of the life cycle. Now, we are going to look in more detail at each stage of the fertilizer life cycle. Starting with the fertilizer raw materials, there are basically three raw materials to be extracted. Firstly, potassium can be obtained from naturally occurring salts like potassium chloride, while nitrogen it can be acquired from natural gas, naphtha, fuel oil, and coal. Lastly, phosphorus can be found in phosphate rock and sulfur. Moving on to the manufacture of fertilizer starts with granulating. One method of granulation involves putting the solid materials into a rotating drum that has an inclined axis. As the drum rotates, pieces of the solid fertilizer take on small spherical shapes. They are passed through a screen that separates out adequately sized particles. A coating of inert dust is applied to the particles, keeping each one discrete and inhibiting moisture retention. Finally, the particles are dried, completing the granulation process. After granulating, it continues with blending. In the process, the different types of particles are blended in appropriate proportion to produce a composite fertilizer. The blending is done in a large mixing drum that rotates in a specific number of turns to produce the best mixture possible. After mixing, the fertilizer is emptied onto the conveyor belt, which transports it to the bagging machine. The next stage is distribution of fertilizers. There are many channels for the distribution of fertilizers from the producers. The fertilizers are distributed to Government Land Development and Rehabilitation, National Farmers Association, wholesalers, private and estate agencies, and users can obtain fertilizers from this channel respectively. In order to help farmers procure fertilizers, the government has stimulated fertilizers consumption through subsidy and credit schemes, facilitated the supply and distribution of fertilizers through FELDA, RISDA, FELCRA, and FOA, stimulated the establishment of a large number of distribution points through farmers' cooperative, improved the cost-value ratio between fertilizers and agricultural produce by providing price support, and provide essential service research on fertilizer use and quality control. The fourth stage is the usage of fertilizer which used for various purposes. For example, fertilizers increase crop yields, improve the quality of food and feed, reduce the amount of cropland required, and reduce the need to convert land to agriculture. The last stage is the end of the life cycle. There are several ways to manage and dispose of the usage of fertilizers. First is to reduce. We should buy only the needed amount or find alternative for fertilizers. Furthermore is to reuse. We should look for others that might be able to use leftover fertilizer. Besides, to dispose of since fertilizers are not recyclable, proper disposal is necessary. To do this, fertilizers stored in a cool dry place and never mix two types of fertilizer together as this could result in dangerous chemical reaction. Then, take unused fertilizer to a household hazardous waste facility. The impacts of fertilizer. How can fertilizer affect the environment? Fertilizers are associated with greenhouse gas emission to the atmosphere during their production, transport, and use. The use of inorganic fertilizer contributes almost 40% of agriculture GHG emissions. Ecosystem health. Excess nitrogen and phosphorus contribute to the eutrophication of freshwater systems in coastal areas. Moreover, excess nutrients also cause the types of pollution of surface and groundwater, soil, and air. Adverse health impacts. Contaminants in fertilizers affect soil quality and may enter the food web through uptake by plants and ingestion of contaminated food or feed. Other than that, toxic trace elements found in fertilizers include mercury, cadmium, arsenic, and lead. First, use of direct finance to encourage sustainable agriculture. Provide financial support to encourage adoption of technologies in practice, and funds may be mobilized. Adopt ecosystem-based approach. This approach uses environmental knowledge and takes into consideration other plant management factors that influence productivity. Providing knowledge and sharing it widely will expand the solution base for farmers and allow adoption of environmentally friendly and sustainable production systems. Next, strengthen global policies on the sustainable and safe use of fertilizers. Partnerships that encourage information sharing between scientists and global policymakers contributes to filling information gaps at the global level. Participation by scientists in such partnerships improves chances that the global policies, decisions, and suggestions emanating from them will be implemented. Thank you for listening and your attention.